In the second part of section 9, we look at maximum and minimums. Maximum and minimums occur at stationary points. So at these points we always know the derivative is equal to 0. At a maximum, like B, point B on the graph, the derivative will go from positive through 0 and down to negative. But at a minimum, like point D, the gradient will go from negative through 0 to a positive value. We can turn these facts into an easier test to see whether a stationary point is maximum or minimum by taking the second derivative, by differentiating twice. If the second derivative is negative and the first derivative is a stationary point, then it's a local maximum. If the second derivative is positive at a stationary point, then it's a minimum. Here's an example. We need to find the stationary points of this curve and see what type they are. So first we need to differentiate. Then we need to find where the stationary points are. These are the points where the derivative is equal to 0. So if we set 3x minus 18 equal to 0, we can solve for x. We can use this value of x to find the y coordinate by substituting it back into the expression for y. So we know there was a stationary point at 6 minus 67. If we look at the derivative of y, we can differentiate this again to find the second derivative, 3. When x is 6, the second derivative is still 3, which is larger than 0. The second derivative larger than 0 means a minimum. So the stationary point 6 minus 67 is a minimum. Here is a typical exam question for you to try. Press pause, and once you've finished doing it, press play again to see the answers. Part A. We need to differentiate this expression. 2x cubed becomes 6x squared, 3x squared becomes 6x, and 36x becomes 36. In part B, we need to find the stationary points and what type they are. So first, we need to find the stationary points. This is going to happen when the derivative is 0. So if we set the expression for the derivative equal to 0, we can divide through by 6 and factorise the quadratic. So we can now say that the stationary points happen when x is minus 2 or x is 3. But we need to know the coordinates, so we also need to find the y value. But we have an expression for y, so if we put x is minus 2 into the expression for y, we get out 44. If we put x equals 3 into the expression, we get out a value of minus 81. So the stationary points are minus 2, 44, and 3, minus 81. Now we need to determine whether they're maximum or minimum. So we have the stationary points. To look what type they are, we need to find the second differential. Here's the first differential. We're going to differentiate again. we need to evaluate this second differential at x equals -2 and 3. So let's start with x equals -2. The second differential has a value -30, which is less than 0. So this stationary point is a maximum. If we put 3 into the expression, we get a value of 30, which is bigger than 0. So this stationary point is a minimum. So finally, we have -244 as a maximum, 3 -81 as a minimum. We'll leave you with the key points from this section.